Minute answer questions are quick conceptual quizzes. If you're looking for one of these questions in particular, watch the lower right hand side of the screen. Now, we're going to take it from the top. A production process that exhibits only natural variation would be considered what? In control. That is the control in quality control. If a process only exhibits natural variation, it's in control. If any other kind of variation sneaks in there, it's out of control. Okay, another term or description for natural variation is what? Random. Another very common term for natural variation is random variation. Okay, now if a point plotted on a control chart falls outside the control limits, what does this suggest? Process is out of control. Because the whole point of a control chart is it's a visual signaling mechanism for the presence or the lack of assignable variation. We assume that if samples fall inside the limits, that's all natural variation, and if anybody falls outside, whoops, we're out of control. That's something other than natural variation. Okay, now, producer's risk refers to what potential mistake? Type 1 error. Okay, what's a type 1 error? Type 1 error is when you declare that something's wrong, oops, when in fact actually nothing's wrong, or in the case of quality control where you declare assignable variations present when in fact actually no, what you were watching was just some particularly odd but entirely random and natural event. Okay, now, to what potential mistake does consumers' risk refer type 2. Type 2 error is concluding that a process is in control. Okay, everything seems to be in control, when in fact it actually is not. What does that mean? That means that you are actually doing things wrong, and since you're not aware of it, you're going to pass that on to the customer, and that's why it's known as the consumer's risk. Okay, next question. Will the variation in sample means be greater or less than the variation in the process being sampled? And the answer is less. The variation in means will always be less than the overall variation in whatever was being averaged to create the mean. Okay, what is the next question? A process capability index greater than 1 indicates what? It's a happy thing. The process is capable is what I'm trying to write, of supporting production. The process capability index is a score. It's essentially a number. If it's higher than 1, that's good news. That means that the process that you're scoring is actually capable of supporting the production that's being proposed. And what we mean by that is it's actually able to support the design specifications reliably. Okay, good. Now, next question. Will widening the distance between the control limits on a mean chart increase or decrease producer's risk if you make, here is a mean chart. If you make the limits wider, you will decrease producer's risk. Now you think, why decrease? Because think about how a control chart works. Okay, if the samples fall inside the limits, we say, okay, everything's fine. If they fall outside the limits, we stop. If you make them wider, it's harder to fall outside the limits because you're sort of casting a wider net, which means if it's harder to fall outside the limits, it's less and less likely that you're going to accidentally stop. That's what the producer's risk is, accidentally stop the process. Oh, all right. Now, how does decreasing the sample size influence producer's risk in acceptance sampling? It increases it. Oh, nice thing, huh? Why is that? Because in acceptance sampling, you have a great big batch, okay? You're wondering whether you should use this batch or not. So you take a sample. The smaller the sample is, the more likely you might accidentally declare this batch to be good and bring it in and make something out of it, when in fact it's not, right? There's a lot of defects or rottenness elsewhere in the batch. The smaller your sample size is, the more the risk that you might not detect that. So that's also the producer's risk of accidentally bringing something in and using it when in fact it isn't of high enough quality. The larger the sample size, the more likely you're to detect something's wrong. Okay, now next question. Theoretically, how does increasing proportion of defects in incoming product influence the probability of accepting a batch? Okay, so you have some acceptance sampling scheme, and we're talking about we're increasing the proportion of defects coming at you. That is going to decrease the probability of accepting a batch. We don't even have to know what your policy is, but we're saying on the incoming side, more defects are showing up. Okay, then it's less and less likely that you're actually going to accept the batch. Do larger sample sizes lead to narrower or wider control limits in a process? The answer is narrower. You can think about the formula for instance, a mean chart. That's just what I scratched there, where the center is, the overall average. Oh, and then z times, well, would take one way to do it is take the standard deviation in the process and divide it by the square root of n, which is the sample size. The smaller, the larger the sample size, the larger the denominator is, the smaller this is getting. Oh, okay, so the larger the samples that you're grabbing, the smaller or narrower the control chart that's appropriate to use to plot those samples, because the larger the samples that you're gathering, the more information you're essentially gathering with each sample, and so it's okay to be pickier, right? Pickier is narrower with your control chart. Anyway, narrower. Now, last question. Do larger sample sizes increase or decrease consumers' risk? Larger sample sizes decrease consumers' risk. Larger sample sizes mean you're gathering more information. Generally speaking, that's a good thing. You are less likely to make a mistake.